Calculate the cell potential at room temperature. So we are given 3Cu 2 plus in aqueous, 2Al solid, 3Cu solid, and 2Al 3 plus aqueous. The standard reduction potentials are the following: E naught of positive 0.34 volts. For the second half reaction, it's E naught of negative 1.66 volts. And to find the cell potential, we know the equation to find the cell potential is going to be cathode minus E anode. So first, we have to figure out which one is oxidizing and which one is reducing. So we can look here. We have a 2 plus charge. So Cu is going from 2 plus to 0. Able to find the oxidation numbers by the charges, or if they're in elemental form, then it's just going to be 0. So for aluminum, it'd be 0 as well. And here the charge is going to be 3 plus. Oh, this is ugly. So if it goes from 2 plus to 0, that means that it is gaining electrons. And I usually use oil rig, which is oxidation is losing electrons and reduction is gaining electrons. There's also Leo the tiger goes grr, which is losing electrons is oxidation and gaining electrons is reduction. I personally like this one better. So in this case, that it is gaining electrons, since it is becoming more negative, it's going to be reduced. By elimination, this one would obviously be oxidized, but we can go ahead and check it. So oxidation is losing electrons, which would be becoming more positive, and that is correct. This one is oxidized. Next thing we would do is split it into its half-life equation, and then we need to balance it out. We don't have any water, any oxygen or hydrogen, so we're fine with that, but we do have the 2 plus charge, so we could add here 2 electrons to give it to balance it out with the 0 charge. On this side, we would add the 3 electrons, and we always want them to be the same number of electrons, so we can multiply this by 3 and this by 2. Okay, so now we're ready to use the cell potential equation, and it is going to be E naught of cathode minus E naught of anode. Another thing I used to know which is the cathode and which is the anode is this. So we have red cat and NOx. So red cat is reducing with the reducing cathode, and NOx is anode and oxidizing. You can also learn that these are consonants, R and C, and A and O are vowels. So now that we know what our cathode and our anode is, we can use it. It's going to be E of cathode, and the cathode in this case is the Cu. So we have 0.34 volts minus, as it says in the equation, the anode, which is negative 1.66. Cell potential. And this would be equal to positive 2.00 volts. Since we did use the cathode minus anode equation, there was no need for flipping or switching signs. You could just input it like that since it was already subtracting.